Too late, sorry. Again. I'll just do a very short recap on what we've done so far. That is last week. Then we'll continue on from where we ended. I think so far so good. We are almost done with the atomic physics part. So hopefully today I'll jump straight to optics. Then hopefully maybe we will even finish the heat our next meeting. This is our second meeting, so we still have two meetings to do. And I told you that for this course, we will be solely doing the atomic physics part. Then we will do the heat part. Then we do the optics. That is how it's divided. And last week, we did the atomic physics part. Is that okay? And hopefully, today we will do the optics part. Then next week, if you're able to finish with the optics part, then next week we'll do the heat part. In fact, relatively, the optics part, we are very familiar with a lot of things there, because the general physics, we did a little optics, and I think we went a little deeper there. So I'm sure that all the things that you'll be doing at the optics part will be just a recap. Is that okay? There will be some things that maybe I'll be introducing, but it will still just be a recap. Okay. So last week I was talking about the fact that we have some history behind what we know today as atom. Is that okay? Anytime someone mentions atom, you know that is the smallest particle we are talking about when we are considering a matter. Is that okay? But the name atom, the structure today, how it works, the configuration, the mechanism, it didn't just appear in 2025 or 2020 or 1990 or 18s. It has a series of uh, scientists that worked on it till we have it today. And I told you that before even the atom came, getting to study something we call the atom, that is very, very small, it's relatively difficult, you know. So before that, there was the Greek, ancient Greek, and the Aristotles. In fact, the ancient Greek is a group, and Aristotle is the leader of, let's say, that group. Is that okay? And we know that they were the people that was explaining the world phenomena to us. Something is not going on well. We go to them and they explain to us. And we in Africa, maybe we can say they are our traditional priest or something. Maybe we are not getting rain for a very long time. We are not understanding, but we go to them and they explain to us scientifically in their own ways, not in any spiritual ways. And interestingly, everything that they were explaining to us wasn't based on experimental basis. It was based on assumptions. Is that okay? And it's okay. This is happening because of this and this. They were just putting their assumptions together. And I told you that even when you threw a stone in the sky, as and now, the two of us know that the only thing that is bringing the stone back to Earth is because of gravity. But they were not explaining it in that way. They were explaining that the fact that the stone has to come to its natural place. Is that okay? And it was very confusing, you know. So with time, Galileo Galilei came and he did a lot of work. In fact, there's even a telescope, a type of telescope configuration that is named after him. Maybe if we are doing physical optics, I will explore. Hello, did my network just shut?
No, because I
No,
can't see the
yes, we
screen.
can see the screen.
The screen is
You
off.
can see the. Okay,
You can see it now.
perfect. So the Galileo Galilei came then. He was trying the fact that all the assumptions that Aristotle was saying, can we prove them? We are saying that the stone is going to its natural place. What are your basis of saying that? Is that okay? So he did a lot of experimental things to one way the other, either align or distinguish or uh, actually integrate what all that Aristotle was saying. Down the line to Isaac Newton also came, which he also did a very powerful work. Is that okay? And it's because of Newton that is how we are able to explain motion. And that is why you are even doing Newtonian mechanics. Is that okay? So everything that we are studying under Newton, Newtonian mechanics, one way or the other, half is from Isaac Newton. We want to understand motions. Is that okay? We want to understand why a car is moving. When I jump out, something happens to me. When I jump out, I'm not going to just jump out freely. There's going to be something that is going to be acted on me. Newton was explaining the fact that when you put something on the table, let a decay come, it will still be there unless we have some external force to act on it. Newton was explaining that the fact that when we, we hit something, there's a force that also reacts to it one way or the other. Is that okay? And it was true, all these experimental procedures and uh, that helped us one way or the other in 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 our car building, in our rocket movement, in even our walking. We know that when we walk, we don't fall because of something. Is that okay? So Newton did a very wonderful work, and but there was a problem again, and I told you that because he was dealing with the macroscopic, he wasn't able to, his laws wasn't able to explain the micro. And when you say micro, very small objects, is that okay? Or particles, that is the atomic size. He was not able to explain that. Is that okay? So that was the limitation of Isaac Newton. Then fast forward, this man came and did also a very wonderful work, Albert Einstein. But all these things started somewhere. And we went through all this last week, talking about, I think we didn't talk about the post, but we spoke about that in atomic theory, we spoke about J.J. Thomson, we spoke about Isaac, Ernest Rutherford, we spoke about his drawbacks. We did hydrogen spectrum, we did Bohr theory, we did the shortcomings of Bohr, and I think we didn't do this. We've not done X-ray too, and we've not done the application of X-rays. So I'll try and cover up these last two. In fact, for this particular one, I don't have it in the slides, so maybe we may skip it. Is that okay? But we'll focus on the X-rays and the application, especially in the medical field. Is that okay? So yeah, the atom has been explained in the of last week, for 4 hours. We spoke about that and being an English teacher who came in to also help in understanding the atom. And you should know that even before they started this thing, the Aristotles and the Greek philosophers has already presumed that there's a smallest particle of a matter. Exactly. So even if they are doing some assumption work, some of them was actually aligned with what we are also doing today. Is that okay? So that thing came to do his. He gave us the atomic theory, and we talked about the fact that some of them remains true and some of them are wrong as at 2025. So we did a very lengthy conversation about it. Then we jumped straight to the discovery of an electron, where we said we have something here that is a chamber, and we call the cathode ray discharge tube, and we have a fluorescence dye behind the anode, and we've pumped all the gases out, so we have a vacuum here. Now when we apply a very high voltage, we expect that there should be some charges here that is going to accelerate towards this anode. As at that time, they didn't know. It's okay. So they were observing if it's true that something is inside a material. Is okay. And this is the experiment that they used. And through that, they discovered the electron. But after discovering the electron, another question was in place. What is the charge of the electron? What is the mass of the electron? And of course, they knew that the charge of the electron was negative because of the magnetic and the electric field that was applied there. But it's negative what? Negative 20, negative 50, negative 1000. We didn't know. Is that okay? And how heavy is this electron? So, there was also a long conversation that we did about this. And I told you that at the end of the day, J.J. Thomson was able to find the charge to mass ratio of an electron. But singly, like finding the charge, finding the mass, he wasn't able to do that. And that is where Millikan came in. So Millikan did an experiment that we call the oil drop experiment. And he was able to find the charge, the value of the charge. And if we have the value of the charge and you have the value of the charge to mass ratio, we can just divide the two, then we get the value of the mass. So as of now, we know the mass of an electron. As of now, we know the charge of an electron. Not only negative, but we know that it's negative 1.6 times 10 to the power negative 19. Is that okay? So let's put that in mind. So he also proposed how the atom supposed to look like. And I told you that he was saying it's the whole positive thing that we are talking about, but we have negative that is distributed in it uniformly. And I told you that a very typical example that we can think about is the watermelon, where the red part that we eat is a positive, and we have the seed like the negative in it. Is that okay? Now, there was another confusion too. So Ernest Rutherford came in with his student to experiment on what J.J. Thomson was telling us. So he bombarded aluminum, a good for with a alpha particle. Alpha particle is positive, very, very heavy positive material. And if you are saying the atom supposed to be all positive, we expect that if a positive is coming to bombard with it, relatively and ideally, they should, or most of them should actually bounce back. Is that okay? But it didn't happen like that. In fact, when he bombarded the alpha particle with the gold core, most of the alpha particle actually went through. So there was another confusion to what J.J. Thomson told us. So Ernest Rutherford did a very lengthy conversation about it concerning what he observed and the explanation and the conclusion regarding that, which we've discussed already. Is that okay? Then from there, he also proposed how he think the model of the atom should look like, pertaining to the experiment that he did. Is that okay? Then, even after his nuclear model or the atomic model, there were still some drawbacks in terms of the stability of the atom, because he proposed that the atom supposed not to look like what J.J. Thomson said, but the atom actually is like we have a positive at the center, and inside the positive too, we have something we call the neutron, and they are all in something we call the nucleus at the center. And the radius of it is about 10 to the power negative 10. And we have another thing we call the electron that is actually revolving around that of the what? Of the nucleus. And we can imagine this as the planetary system, where we have the sun and we have the sun behaving like the nucleus containing the proton and the neutron. And we have the planetary system. And the planetary system actually serves as, say, the electron. And they all have their paths that they are traveling. So there's no way Earth is going to crash with Pluto or Mars, is that okay, or Venus, is that okay? So they all have their path they are traveling. But the thing is, anytime there's a travel, in fact, he stated that the only thing that is keeping them is the electrostatic force of attraction. So it's never collapsed. That is fine. But anytime it is moving, it constantly dissipates or emits radiations. Is that okay? Because of its movement. But the energy that is going to use to dissipate this radiation, with time, it will go low or it will go down because it's losing energy. And with time to it may crash. So that was one drawback of Rutherford's model. He couldn't explain that. He couldn't explain the energy levels. When you say energy levels, which of the electrons tends to. Am I online? The way I've been talking for the past 30 minutes. Are we listening, please?
Yes, sir. Yes, sir. Yeah, understand.
Yes, sir.
We are following.
Yes, please.
Yeah.
Okay,
Yes.
great. The other thing that he wasn't able to explain was Francis, please, your hands is up. Hello, Sir Francis.
Sir, sorry, it's a mistake, please.
Okay, that's fine. Another thing that he wasn't able to explain was the energy levels. In fact, which of the electrons tends to stay at the first shell? Which of them tends to stay at the second shell? Is it that if you have high energy, you get to stay close to the nucleus, or you get to stay far away from the nucleus? Is that okay? Rutherford didn't explain that to us. Is that okay? So the students also came in, and I told you how scientific research works. Anytime a professor is working, his student does the same work and continue on with where the professor ended. Is that okay? Or take a particular field of the professor and grow in it. And it is done everywhere, even in Africa here. So for me, my supervisor is working on, we are doing something like called applied spectroscopy, which I am also in it. So one day I grow to become on my own as a full researcher. It's the same thing I'm going to do. I may also pick up a student to dream in that. Is that okay? That is the continuity of research. We all do the same thing. So you look at your interest, then you choose a supervisor and you continue with that area that is in. Is that okay? And it's the same thing Rutherford and his students was doing. So James Chadwick came to also continue on with where the Rutherford ended, exactly, to explain the drawbacks of him. Bohr also did the same thing, and Bohr also gave us a very important 4 principles of the atomic model. And last week, I explained to you that from Bohr's theory, we can find the radius of each shell, exactly. And the only thing that we need is the principal quantum number. Principal quantum number is the shell that the electron is on it. Or how should I explain it? Yes, so shell 1, shell 2, shell 3, shell 4. Is that okay? So that is the only thing that we need, because at the end of the day, the A naught here is a constant. Is that okay? So we just have to put the value in here. Then you multiply it by the what? The square of the principal quantum number. And that will be all. And we also explained the energy levels. I told you that it is very possible for us to find the energy levels of each principal quantum number. And the only thing that we need is the Rydberg's constant. And that will be all. Is that okay? So if you are finding for the first energy level, we just will multiply the Rydberg constant by 1/1 squared here. And then we get our first energy level. We can find for the second energy level, we can find for the third energy level, depending on the stationary state that we want to find, or the principal quantum number that we want to find. So it is very important. So we went through all this thing, and I told you that apart from the energy level, we can find the wave number, we can find for the frequency. It's just a matter of just doing a little change of subject. And we can find for the change in energy, whether we are going high, we are going low. When I say we are going high, if it's at principal quantum number 1 and it's going to a higher principal quantum number, we can find the energy. we know that if it's going higher, it's supposed to absorb some form of energy and go high. And if it is at a very high level, let's say at principal quantum number 5, it's coming down, it means that it has to dissipate some form of energy. Is that okay? Then we also spoke about the limitation of Bohr. Then I ended with quantum mechanic model of the atom. Then I think we solved this. Yes. Then I think I have the solution here. Okay. Then I think we did this and I have the solution to here. Then you're supposed to do H3. Any questions so far before I jump to the H3? Please, any questions so far?
No, sir.
Hello, sir.
Okay.
Please, what you just displayed, is it in our slide? Well, I want to
Yes, it's
snap
in your
it, but
slides.
you have removed it from the various inventors and their contribution. Okay,
Yeah,
sir.
I think it should be in. It should be in.
Thank you, sir. Okay, sir. Thank you.
Okay, so let's go on to H3 if there are no questions so far. Okay. So when we say H3, what comes into mind? Do we know H3? Have you ever heard of the word H3 before?
Yes.
Yes, sir.
So what is
again,
H3? When you mention H3, what comes?
please, it's a machine used for taking internal, taking picture of the internal organs.
Okay.
So
Taking pictures
Like
of
the
yeah,
the
bones, because
electromagnetic
last time
radiations.
I had an accident.
So let's do it one after the other. Christopher, you finish, then maybe Frank comes in.
Last time I had an accident and they use it to snap my bones to see whether just broken.
Okay. Okay.
That was why I said yeah, some machine used for taking the picture of the internal organs like the bones and the other things.
Okay. Any different input?
Yes, sir.
Yes, sir. Let
So,
me.
sir,
Okay. Okay, Frank, you go. Frank, you
okay.
go before.
Yeah, what I want to say is that they are electromagnetic radiations. Yeah, they are produced by electrons, the movements of electrons.
Okay, Frank.
Okay, sir. Let me add to what Frank just said. They are electromagnetic wavelengths. They carry a high energy, and they also have a shorter wavelength, which happen due to fast movement of electron. Electron have to move fast. As a result, the body it can produce the X-ray. Thank you.
Yeah, okay. Okay. Any different inputs? I think last week I explained H3 a little. Oh. We did electromagnetic radiation. I explained X-rays in terms of their energy, in terms of their wavelength, in terms of their frequency. So when you are explaining that in that perspective, what is X-ray?
So we say that X-ray are highly energetic electromagnetic wave of
Mm,
either shorter or longer wavelength
mm,
that are produced due to a fast movement of electrons. Electrons are moved fast that are brought closer to a rest by a body.
okay.
So we said that you said that the one with the shorter wavelength have a higher frequency, and the
Mm,
one with the longer wavelength have a lower frequency. And that also based on the penetration power or the energy level that it has.
okay. But when how many of us has had an experience with X-ray before? In quotes, the X-ray machine itself. How many of us had any experience, any form of experience?
I've experienced some before.
Okay. So apart from say Christopher, any other person?
Yeah, me too.
Yeah.
From
Okay. Okay, Frank and David. Then who again?
And me too, sir.
Okay. Sir Peter too.
So
Okay.
because of the fear, because of the fear, we don't want to go closer to it. So some of us
Oh
have no
no,
go.
come on. If you need it, you have to use it. Okay, but Sir Peter Azuma, how did they use it on you? Do you remember the procedure that you passed through before taking the images and all?
Okay, it's quite long though, but what I can
Mm,
remember is that so when I visited the hospital
mm,
and they want to pass the X-ray on me, they asked me to lie down on the bed. They provided me a bed. So and I sat on it. It was my leg. I
okay.
was having a leg problem. So they
Mm,
wanted to check the bone, whether there is a fracture there or not. So they asked me to place the leg on the small bed they have provided for me. So when I placed it there, there was a light, like a bulb on top.
mm,
So when they on the light, I was seeing some uh reddish this thing,
mm,
light line, like a cross,
mm,
like a positive, the sign of positive. So they asked me to place my leg in a position. So when I placed the leg, that light was where I was experiencing the pain. No? They let that light, that red light, like a cross, like a plus
mm,
sign. So to be situated on where I was experiencing the pain.
mm,
So they kept it there for some minutes or seconds. So and they asked me to shift my distance, my leg back. So and I shifted. So by then, they then went back and I don't know what they did. So small time they asked me to come to a very big machine or like big screen. So by then it's like they have printed some distance, the image of the bone. So they
mm,
then went and placed that distance, that thing they have printed on that wide screen machine with light. So that the light can reflect or it can pass through so that I can see the bones well, or I can see the image well. So when they place on the machine, on that screen, so they provided me a chair to come and sit down and then watch. So when I came and sat down, I was watching. They asked me that, am I seeing everything clearly? And I said, yes, I'm
oh, okay.
seeing everything. So at the end of the day, they told me that they also took the other part, the other leg. So they asked me to look and tell them some difference there. So,
Mm,
and I looked at it critically and I was seeing that there was some difference somewhere. And I was able to point to where I'm
mm,
seeing the difference. So they told me
okay.
that place, the bone has had a crack, that small
Okay.
one.
Okay.
That it has a crack, small one. But they said
Okay.
that they work on it, that the crack will go back. So, but that's
Okay.
just what they want me to see, to know, so that I will get to know what is happening with the bone.
What's
I'm
happening to
experiencing the
you?
pain.
Okay.
So that's
That's
what I
fine.
remember.
So Zuma, thanks for your experience. Sir Christopher, do you want to come in? I want to know how your image was taken.
I climbed a tree cut down, so when I went to the hospital, they told me to remove all my dress and they gave me their overall. So I lie flat on the machine. And because I was staggering, even I couldn't open my eyes before I realized then they have finished everything. And then when they brought it, I got to know that my backbone I've gotten some fractures on my backbone. So I was taken to another hospital, that is 37. That was my experience.
Sir Zuma, sorry, Sir Christopher, I lost connection for a minute. Please come again. Sorry.
I said for me when I went there because I was unconscious, they removed my dress and gave me overall. They asked me to lie flat on the machine. So after the picture, then they showed to my parents, and I had some fracture on my backbone. So I was taken to 37. So that was all what I saw.
Okay, and that is fine. So I think I've taken X-rays like 2 times or maybe 3 times,
Okay.
and I'm also talking about my experience. Oh, I think it should be
Okay.
more than 3. I have done another one too with my gum, my teeth. But has anyone taken X-ray with the teeth before? Apart from the body parts, has anyone taken X-ray with the teeth before? Oh, okay.
Yes, sir.
You have?
Yes, sir.
Okay, so how was the experience? What is the procedure that they made you pass through before taking it?
When I went there, they told me to rest for some time. So after that, they put something into my mouth. They washed my mouth and then they placed something into my mouth. Then they put the machine there. They snapped the picture 5 times, but they couldn't get what they wanted. So later on, when they showed the picture, and my teeth I've gotten a lot of fractured on my teeth because of the accident I had.
Hello. Am I the only one who's not hearing you?
Me too, I'm not hearing
I'm
anything.
also not hearing anything.
Yeah, please give me a minute.
And
Sorry.
the same thing here too.
Okay, sir.
Please, a minute. Please, a minute. Yeah, hello, class. Hello.
Hello, sir.
Hello, sir.
Please, I'm sorry. I had an emergency call. Can the class pardon me? Then I'll go offline, then come back at 9 o'clock.
Yes, sir.
It's a plea
Yes.
that I'm pleading.
Yes, sir.
Okay.
Since it is a
I beg of you. Yeah, it's not really emergency, but I am teaching you in the house. I've called that I have to
Okay.
come to the office right now. So to come check
Okay.
something in the lab. So, and I've not even taken my bath. So coming to take my bath and getting to the office to solve the problem there, it may take like an hour.
Okay.
So I'm patiently and begging you about this. I beg of you. I need only 1 hour.
No problem. No problem, sir.
Okay.
Thank you very much. So please, exactly 9
That's
o'clock.
okay, sir.
Yeah, exactly 9 o'clock. I'll come online then come and start. Is that okay? I'm just
Okay.
begging you so that no one goes online to go and talk about it that I have stopped the class. Please, I'm
Oh,
just
no, no,
begging.
no,
I
no.
beg of you. Okay, thank you.
Huh.
So I'll see you very soon.
Okay.
Okay.
Bye.
Bye.
All right, so let's continue. X-ray experience. Let's go.
What I said when I went to the hospital, they placed some flat substance into my teeth and they snap pictures. So after that, then they showed me the results. That was all my experience on my teeth concerning the X-ray.
Okay. Is there anyone who also have any experience?
Hello. Hello. Hello.
What's happening here?
Hah? Bukan. Namun lu kamu bang. Ya lama ali le kama kenal lama dari. Ko ni winta ko pulo ko. Ko ni wono kata mana.
Hello. Hello.